Okay, Algebra 2. We're going to dive into factoring a little bit deeper now. So you guys have factored polynomial expressions in earlier lessons and also in earlier algebra courses. Today we're going to explore more techniques for factoring polynomial expressions. We're going to factor by completing the square. We're going to factor by applying the quadratic formula, and we will factor by grouping. So 3 ways we're going to factor today: by completing the square, by the quadratic formula, and by grouping. Grouping is probably my favorite because it's sort of fun how it works out. So the idea of the greatest common factor is important in this lesson. Remember, greatest common factor are two numbers that multiply together to get a number. So we'll use that as we move on. So let's get started. Our classwork, what's example 1? So it says find all real solutions to the equation given. Okay, that means we need to factor these two trinomials. Have you guys learned how to factor these? What do you know? What are the obstacles in factoring? So these expressions, there are 2 of them, this trinomial and this trinomial. There are obstacles to factoring these things. They don't factor quite as easily as examples from previous lessons. They're not perfect squares, they're not perfect cubes, etc. So they're actually a bit harder to factor. This is where we're going to dive into completing the square. I know how I complete the square, and I know how this current book is teaching how to complete the square, and I'm not sure how you learned how to complete the square. So I'm going to teach you how I've learned, and if you know a different way that you're comfortable with, I'm sure I can follow along, and as long as you show your work, there won't be a problem. As long as you get the same answer. Remember, it doesn't matter how you get there as long as it's correct. I'm going to take one trinomial at a time. I have x squared minus 6x plus 3 equals 0. I was always taught to move the constant to the other side of the equal sign. And then we're going to add and add. Okay? Now, what do we put in that box? Now, when there is no a term, then we just take what's in front of the x term, divide by 2, and square it. And that's what we put right here. And since we're adding to both sides of the equal sign, it's a valid algebra move because we haven't altered the equation at all. Now what you see here is I have a trinomial that I can factor. I can do x minus 3 quantity squared equals 6. Cool? This trinomial right here is x minus 3 times x minus 3. You can go ahead and FOIL that if you'd like to double check. Now when we're completing the square, we can take the square to both sides, and I have x minus 3 equals plus or minus the square root of 6. If you remember, whenever you square root something, your answer gives you a positive or negative result. For example, if we have a squared equals 25, and we take the square root of both sides, you get a equals plus or minus 5, because negative 5 squared equals 25, and 5 squared equals 25. So we have to include both the positive and the negative. And that's what we're doing right there. All right. So to finish our answer, we add 3 to both sides, and we get 3 plus or minus the square root of 6. Now you can leave your answer like that, or you can write x equals 3 plus the square root of 6 and 3 minus the square root of 6. Because when you have a trinomial that's a second power, you're going to get two answers. Okay, let's do the other one. Okay, let's hope I have enough room to finish this one. I have 2x squared minus 4x minus 7 equals 0. I need to factor a 2 out. X squared minus 2x minus 7 halves equals 0. And a really cool algebra move, I can divide both sides by 2, and that thing just disappears. So I'm left with x squared minus 2x plus a blank equals 7 halves plus a blank. Now what do I put in that blank? I take the coefficient of my x term, divide by 2, and square it. So I add 1 to both sides. That leaves me with x minus 1 quantity squared equals 7 halves plus 2 halves, 7, 8, 9 halves. Square root of both sides. X minus 1 equals 3 over the square root of 2, which we do not like. X, would be plus or minus. X equals 1 plus or minus 3 over the square root of 2. But I need to rationalize that, don't I? Multiply by square root of 2 over the square root of 2, and I'm left with 1 plus or minus 3 square roots of 2 over 2. All done. So I have 1, 2, 3, 4 solutions. Phew. All right, exercise 1. Factor and find all real solutions to the equation given. Okay. With this example, we're going to use the quadratic formula. Okay, I'm sure you guys remember it, but we're going to go ahead and review it anyway. Basically, it says x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. And your equation has to be in standard form. Oops. It's ax squared plus bx plus c equals 0. All right, let's try it. Let's try it with the first one, and then I'm going to let you do the second one by yourself. First, we have x squared minus 2x minus 4. So negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. 2 plus or minus the square root of 4 plus 16 all over 2. 2 plus or minus the square root of 20 over 2. 2 plus or minus 20 is 4 times 5. The square root of 4 is 2. Okay, be careful canceling out those 2's. I can factor a 2 out and then cancel it. Oh, I forgot my minus. So my answer is 1 plus or minus the square root of 5. That gives me two answers, 1 plus the square root of 5 and 1 minus the square root of 5. So go ahead and push pause and try the quadratic formula for your second one. Try it on your own. So for the second one, I got negative 3 and 1/3, and we did the first one together. So there are 4 solutions. Because I have x to the second power and x to the second power, if I multiplied these, I would have x to the 4th power, which means I need 4 solutions, if at all possible. Now, some of our solutions may be multiplicities, but when we're actually calculating them out, we would list them all. Cool. All right, next example. Find all solutions to this equation by factoring the equation. This is where we're going to factor by grouping, and I've always enjoyed this. I don't know, it just seems like a fun puzzle that always works out. When we factor by grouping, we sort of put parentheses around the first two and parentheses around the second two and see if we can see any patterns. In the first binomial, I can see that I can factor out an x squared, and I'm left with x plus 3. In the second binomial, it looks like I can factor out a negative 9, and I'm left with x plus 3. Notice I factored out a negative 9, which made this an addition. Okay, it's a positive. When I factor out a negative, I have to change this to plus, because if I distributed this back, I would have minus 9x minus 27, which was what I had in the first problem. Now if you see, I have an x plus 3 here and an x plus 3 there. I'm still at equals 0. I can factor that x plus 3 out of both problems. Out of both, I guess, the left side of the subtraction and the right side of the subtraction, for lack of a better way to say it. I'm going to take an x plus 3 out, and I'm left with x squared minus 9. Now I'm good to go, right? I can factor that x squared minus 9 again. X plus 3, x plus 3, x minus 3, because that's the difference of two squares. And I can write my answer. X equals, for this one, I've got negative 3, and 3. I like factoring by grouping. It's always been fun. One thing we should discuss is, how do I know if I can factor by grouping? Well, luckily, in most of the problems that you're given, if you start out with an x to the third power, I would see if you can factor by grouping. Put parentheses around the first two terms, the highest power and the second highest power, and then the last two terms, and see if there's anything in common. Like, I could factor out an x squared, and I'm left with x plus 3. If I look at this, I'm like, oh, I bet I can get an x plus 3 again. Just see if you can find anything in common, and it usually works out when it's an x to the third power as your lead term. Okay, let's try it again. Find all real solutions. Go ahead and push pause and see if you can figure this one out by yourself using the patterns that we just learned. Okay, there we go. A little reminder, I have x to the third power, so I should have 3 solutions. Find all real solutions to this one. Okay, go ahead and try on your own. Push pause. There you go. Okay, not too bad. We have a plus or minus square root of 2, which isn't a huge deal. Good job. Okay, in closing, we have our lesson summary. So in this lesson, we learned some techniques to use when faced with factoring polynomials and solving polynomial equations. We learned that 4th degree polynomials can be factored into 2 quadratic expressions, ax squared plus bx plus c, ax squared plus bx plus c, and then we can use the quadratic formula. We can complete the square, and then x to the third power, we can factor by grouping, which works pretty well. So the 4th degree polynomial can be factored into 2 quadratic expressions, and then each quadratic expression can be may be factorable using the quadratic formula or by completing the square. And then some 3rd degree polynomials can be factored using techniques of factoring by grouping. And that's all we have for today.